Hello everyone, welcome back. So in this video, we're going to learn reduction of order. So there are two cases, but we're only going to talk about one case, which is when the dependent variable y is missing from the differential equation. So let's get started. All right, so here's a typical example of reduction of order when the dependent variable is missing. So you can see that in this differential equation, y term is missing. So since y is the missing variable and it is the dependent variable, we're going to make the following substitution. So if that's the case, we're going to use let v, we introduce another variable, v is equal to y prime. So that means if I take the derivative of v respect to t is equal to y double prime. So that's the substitution we're going to make when you have this scenario. So before I substitute, I'm going to go ahead and solve for y double prime by just simply dividing both sides by t. Since t is greater than 0, I'm allowed to do that. So we have the following equation. We have y double prime plus 1 over t times y prime is equal to, now 8 over t, that's just 8. Well, now we can make our substitution. So y double prime is going to be v prime plus 1 over t, y prime is v, is equal to 8. Now this is a first order linear equation. So we are able to reduce the order to first order and it becomes something familiar, and it's a linear first order equation. So hopefully you remember how to solve linear equations. You have to find an integrating factor mu, and then from there you proceed. So let's compute the integrating factor mu. So mu of t is going to be e to the integral of p of t dt. Now p in this case is this function right here. It's always the function in front of v. So if I substitute that, I have e to the integral of 1 over t dt. And we all know by now the integration of 1 over t will just be ln of t. And no need for absolute value since t is already positive. And this would just simply be t. So we know mu is t. So now we take our differential equation and multiply both sides by mu. So we have v prime times t plus, so 1 over t times t, that's just 1 times v is equal to 8t. Now keep in mind that the left-hand side is actually the derivative of the function mu, which is t times v. And the right-hand side is just 8t. So that's something you want to keep in mind. And now from here, we go ahead and integrate both sides. So let's go ahead and do that. So we're going to integrate both sides respect to t variable. So on the left-hand side, the derivative and integration will cancel out. So we have t times v is equal to 8t squared over 2, which is simply 4t squared, plus a constant c1. Let's put it c1 now, because there's going to be two constants for this equation, since it's a second order. Now let's go ahead and solve for v. So v is equal to, now if I divide both sides by t, I will have 4t plus c1 over t. And now I can bring back what v was. Well, v we said is going to be y prime. So now we can bring in y into the picture. So replacing v with y prime, we have y prime is equal to 4t plus c1 over t. Now I can go ahead and integrate both sides. And we're almost there. And we're integrating respect to t. So we have y prime. If I integrate that, well, I have my function y of t. That will give me 4t squared over 2, which is simply 2t squared, plus c1 over t. If I integrate that, that's simply c1 ln of t. And I have another integration constant, c2. And there you have it. That's the solution to this second order differential equation using the method of reduction of order. Okay, so that's it. Hopefully you enjoyed.